Good afternoon, calculus type people. I hope you're having a fantastic day. Today we're going to be continuing on our discussion with Who put this pen here? Much better. Today we're going to be continuing on with our discussion on antiderivatives. Now, random thought. Let me show you something. Just hang on. Let me show you something. Hang on. Let me show you something. Where am I at? Hang on. Just hang on. Let me show you something. This guy. You see this guy? These are called integration tables, and I just want you to look. This is how many different formulas for integrals that you have. 13. 28. These are all the different kind of possibilities that you could come up with as a calculus question. 45. 74. 100. And there's actually more. There's so many. Now, are you going to remember every single one of these for the test? No. No, you're not. Am I going to require it or you remember every single one of them? No. That's impossible. How could you possibly think about doing that? But what I am going to require is that you remember certain ones. And those ones we're going to go over what we've done already, the ones from yesterday, and then today the other basic integration rules. These are the basics. Okay, these are the basic trig ones, really. And what they're doing is starting out with a bunch of derivatives and finding the integral of them. So really, these are kind of just the nitty-gritty. These are the ones you need to know. Okay, the ones we cover in class are the ones you're just going to need to know. Now, are you going to be tested over them? Maybe not. But will you be tested over them? Maybe. I don't know. I don't know what the test looks like. I mean, I know what it looks like, don't get me wrong. I don't know what the questions are they're going to ask. So you do need to know how to look one up and reference one if you have to. And this is some of the stuff you just kind of have to know, unfortunately. It is a lot of memorization. All right? So let's talk about a question here. The integral of cosine is sine plus c. The integral of sine is a negative cosine, don't forget that guy, plus c. If there's going to be some that are going to be tested, I can guarantee it's going to be these two right here. I guarantee it. The integral of secant squared is tangent. And these are some other kind of obscure ones. The integral of secant tangent is secant. The integral of cosecant squared is negative cotangent. The integral of cosecant cotangent is negative cosecant. I can almost guarantee you will see one of either number 1 or 2, if not both. I can almost guarantee that. I'd almost be willing to bet my paycheck on it. But the other ones, it's good to know how to use. So, for example, number 1 here, find the integral of secant y, tangent y, minus secant y, dy. Finding the derivative with respect to y. Fantastic. That means I don't have to do dy dx and all that junk. The first thing I would do here is multiply secant through to both of these. So it's the integral of secant y tangent y minus secant squared y dy. And what that does is it lets me use stuff from up here because I know that the integral of secant y tangent y is secant x plus c, and the integral of secant squared is tangent. Right? So I can just come down here and say that my derivative is secant y, that's this one right here, right? Secant x tangent x is secant x, so secant y tangent y is secant y minus the antiderivative of secant squared is tangent of y And I'm going to save my plus c for the end. Now, I don't have to do secant y plus c and tangent y plus c and then combine them to 2c, because c just stands for a number I don't know. It could be 2c, it could be 1,000,000c. Who cares? It's a number I don't know. So just combine all the c's into one c. Kind of like the oceans. If you're out, lost on the ocean, are you really going to know when you go from, oh, I don't know, the Atlantic to the Pacific to the Indian? Are you really going to know that if you're out at lost at sea? No. So all your C's can go together. That's why I said that. Okay. Example number 2. Find the equation for y given the derivative and through the indicated point. This is a good question. I like this question. You will be asked this question quite a bit. And I like this question because they give you a graph. Yeah! Okay, so here's the derivative, right? Let me go in on this one. Here's the derivative. It's x squared. So that must mean that the function is the antiderivative of x squared with respect to x. Right? If the derivative is x squared, then the function is the integral of x squared, or the antiderivative. So let's figure out what it is. This is going to be x cubed over 3. Remember, it's x to the n plus 1 over n plus 1 plus c. Fantastic. We have found f of x. But then it gives you 3, 8. Now that is going to change this game for us. That's going to help us find c, and that's what I like this graph for. You see this graph? This is called a family of curves. This represents 5, represents 5 of the possible curves from this line. See, depending on what c is, if c was up here, if c is 3, then it'd be up here. If c is 2, it'd be right here. If c is -1, it'd be down here, right? These are just 5 of the possibilities. Now, these keep going infinitely, and they also fill in infinitely right here. Because if it's plus 1/2, then it'll go right here, right? So this is called the family of curves. It's all the possibilities, right? All the different possibilities of what it could be. So that's just to give you a visual of what this looks like right now. Now, once we use this point to figure out what C actually is, then it's going to restrict this down to just 1. Because only one of these is going to go through this point. Okay? So I'm going to plug in 8 for y and 3 for x and figure out what C is. Plug in 8 for y, plug in 3 for x, there's my x, and solve for c. Well, this is 3 cubed over 3 is 9, right? So subtract your 9 over there. C is -1. So now all I have to do, and I'm sorry for these 2 lines on the paper, but now all I have to do is rewrite my equation. F of x is x cubed over 3 minus 1. And now I have a specific function that I can model. And it happens to be this one right here. All right? So again, this just represents all the possibilities of what it could be. Once I restrict it and find out what C is, bada bing, bada boom, I'm ready to go. All right. Again, I'm sorry for the lines. That's the copying issue. Find f if f double prime of x is 12x squared plus 6x minus 4. And then they give you f of 0 and f of 1. So if you notice here, they've given you 2 conditions. These right here, we call them the IC. These guys right here, are called initial conditions. Oops, sorry. Initial conditions. And I have made 3 trips over there, and I'm going to make one more because my pencil is getting dull. I can't believe this. I should be more prepared. This is also the bad thing about recording on this method because you can't pause anything, even when I want to. Okay, so these are the initial conditions, right? So let's actually figure out the question here. It says that this is f double prime. So the first thing I'm going to do is start off as saying f prime of x has got to be the integral of this. So I'm going to say f prime is the integral of 12x squared plus 6x minus 4 dx. Now the plus c doesn't come until after you've integrated, right? So let's figure out what this is going to be. This will be 12x to the third over 3 plus 6x squared over 2 minus 4x to the 1 over 1, which is just 4x, plus c. Now, if they had given me f prime of 0, then at this point I'd plug this in just like I did in the problem right before it. But these are both dealing with f, so I can't do anything right now. So what I'm going to do is figure out what f is. It's the integral of this guy. Now 12x cubed over 3, 12 over 3 is 4, right? 4x cubed plus 3x squared minus 4x plus c dx. Now again, I don't know what c is yet. I've got to figure that out. So let's integrate it. 4x to the 4th over 4 plus 3x to the 3rd over 3 minus 4x squared over 2 plus c. Now this c is a number, right? And I'm going to treat it as such. So I'm just going to say c to the x plus, now I have another constant out here because I've integrated it again. So let's just call this one d because I don't have a better term for it. So as of right now, it really looks like I'm kind of stuck. I've got 2 numbers that I have no idea what they are. So at this point, I'm going to look back to my initial conditions. And it says that f of 0 is 4. F of 0 is 4. Well, that means if I plug a 0 in for all of my x's, I get 4, right? Let me bring this down here. Let me think this through. F of 0 is 4. So that means if I plug a 0 in here, we can simplify this, right? It just x to the 4th, x cubed, 2x squared, cx and d. But if I put a 0, this 0 in for all of these x's, what's going to happen? I'll get 0 divided by 4 times 4. Sorry, let me focus that. Plus 0 minus 0 plus 0 plus d. 0 plus 0 plus 0 plus 0 plus d. That tells me, therefore, d has to equal 4. If I plug in a 0 for all these x's and I'm supposed to get 4 out of it, the only thing left is d, so d has to be 4. All right? Now, I am skipping a few steps here, but that's okay. Just follow along with me here. So let's rewrite it. Let's rewrite our equation here. I'm going to say f of x, and let's simplify this. This is x to the 4th plus x cubed minus 2x squared plus cx plus, and I'm going to call D 4. Because I know that if I put a 0 in for all of these x's, I have to end up with 4. So I'm going to call D 4. And now I've only got one thing missing. So now I can use my other one. Plug in a 1 for x and a 1 for y. 1 is equal to 1 to the 4th plus 1 to the 3rd, 2 times 1 squared plus c times 1 plus 4. And then solve for x. So it looks like I've got 1 is equal to, let's see, 1 plus 1 minus 2, so those will all go away, plus 4. So it looks like I'm left with c plus 4. Bring your 4 over, and c is negative 3. So I can come over here and I can write my equation, f of x is going to be, from here, x to the 4th plus x cubed minus 2x squared minus 3x, because this c is a negative 3, plus 4. Remember what I told you yesterday about working backwards? The derivative of this, let's go back here. This should be right here. 4x cubed, 3x squared, minus 4x, minus 3, which is your constant, your plus c. Take your derivative there, you're back there. Perfect. All right. So again, let me just kind of big picture this one. We started by taking the antiderivative, and we got a plus c out here. Then we had to take the antiderivative again to get to f, but we had two variables now, two different coefficients, two numbers. The c is now a coefficient for x, and d is a constant. It's not changing. It has no x on it. Since I knew that if I plug in zeros for all my x's, I just get d is equal to 4, then I can make d 4, plug in the second initial condition, solve for c, write out your equation. Now, that's a lot. I know, that's a lot. But trust me, once you get used to doing this whole integral stuff, it starts coming pretty much just as easily as derivatives do. Okay? So let's actually do an application question now. Number 4. Here we go, particles in motion. A particle moves in a straight line and has acceleration given here. Its initial velocity, v of 0, is negative 6, so they just gave me a point. When time is 0, your velocity is negative 6. And its initial displacement, s of 0, is 9. Okay, find the position. They want me to find position given acceleration. So I'm going to underline those right there. Now remember, acceleration is what we're given. That's the derivative of velocity, and the second derivative of position. Okay? So if I start with acceleration is 6t plus 4, then my velocity, v of t, is going to be the integral of this. Oops, dt, excuse me. dt. So let's take the integral of it. Let's see what this is going to be. This will be 6t squared over 2 plus 4t plus c. All right, now I'm going to go ahead and simplify this here. It's going to be 3t squared plus 4t plus c. And what they have done is they have given me an initial condition. They said that my velocity, I have my velocity now, this is v of t. they said that velocity when your when your t is 0, velocity should be 6. So I'm going to do that. I'm going to set this to -6, my velocity, plug in a 0 for t, and solve for c. Well, this is the same situation I faced on the front. 0 plus 0 plus c, so c is -6. Right? So your velocity function, v of t, is going to be, put a 6 in here. 3t squared plus 4t plus 6. Now I'm going to need that, but that's not what the question is asking. The question wants me to find its position, so I'm going to have to do that one more time. So, coming up here, position, s of t, is going to be the integral of velocity. 3t squared plus 4t plus 6 dt. So let's do it again. S of t, so let's set this up here. It's going to be 3t squared, or 3t cubed over 3, right? 3t cubed over 3. Eventually you'll get to the point where you can do this part in your head and you can simplify it right away. Don't rush it. There's no point. 4t squared over 2. Remember, it's the exponent plus 1 over that number, plus 6t, plus, now, since I already solved for c, just to keep myself from getting annoyed, I'm going to use d, so I know it's a different number. It's not -6. If you already give c a value, don't call this c, because that's going to say, oh, well, it's -6, and it's not. And then I have an initial condition that s of 0 is 9. So if I plug a 9 in for s of t and a 0 in for t, I should figure out what d is. 9 is equal to, this will be 0 plus 0 plus 0 plus d. Well, that's easy. So d is 9. And your big answer here, s of t, your position. Simplify this. This is t cubed plus 2t squared plus 6t. Wait. Oh my gosh, I can't believe I did that. I forgot that's a negative. That's okay, it doesn't change a lot. It doesn't change a lot. This is just going to be a minus. I'm so sorry. This is a minus, and it makes all your 6's minus here. So minus, minus, and minus. Minus is everywhere. I'm so sorry. I should have caught that. I did catch it. I should have caught it sooner. Minus 6t plus 9. And that, my friends, my dear students, my pupils, is antiderivatives.